Welcome back to another video here on the Unknown Coder YouTube channel. As always, I am Ethan, and today we are doing merge sorted array here on LeetCode. This is another one of those problems that is a little bit tricky, and it's pretty common to see around, so this will be a really good one to tune into. So the problem is going to state we're going to be given two arrays, one called nums1, as we can see here, and then another one called nums2, as we can see here. Something that is important with this problem is that these nums arrays are going to be sorted in non-decreasing order. This basically means that the smallest numbers are going to come first and the largest numbers are going to come last. Something else that it mentions is that it's going to also include two integers, m and n. This is basically going to be because they're giving us extra space at the end of nums1 array to go ahead and merge in the values of nums2 array. So this is how we're going to actually be able to tell how many values are inside of the first array. And then finally, obviously the goal of this is to go ahead and merge these two arrays back into array number one. But this is the reasoning behind the m and n variables, because nums1 is actually going to have n plus m length. This is just saying that it's going to be the size of array 1 plus the size of array 2. That way that there's space inside of the final array to actually put all of the values. So let's go ahead and take a look at a couple of the examples to see how things are going to look and how our ending arrays are going to turn out. For our example number one, we're going to have obviously two arrays. So nums of 1 is going to be an array with 1, 2, 3. Then it's going to have 3 spots at the end to be able to hold values from array nums2. Then our m is going to equal to 3 because we just want the first 3 values right here of this array. And then our nums2 is going to equal to 2, 5, and 6. And again, n here in this case is going to be equal to 3 because we are looking at these first 3 values. Now, how we are going to solve this is we're going to basically go through both of these arrays and determine which one should go into the beginning. So what's going to end up happening is our output is going to look something like this. So we're going to have nums1 equal to, and we're going to have 1 because it's going to come from nums1. We're going to have 2, which comes from nums1. We're going to have 2, which comes from nums2. We'll have 3, which comes from nums1, 5, and then 6 coming from nums2. So we need to loop through both of these basically at the same exact time and figure out which number is larger or smaller. That way we can place it inside of the array as needed. Now let's go ahead and take a look at the second example. So for our example number 2, our nums1 is just going to have 1 inside of it, and then m is going to equal 1 because there's only one value, and then nums2 is going to be an empty array, and n is going to equal to 0. So in this case, obviously we don't have anything to merge out of nums2, so the output nums1 equal to 1 because again we don't have anything to merge. And then let's go ahead and take a look at the final example they gave us. So in example number 3, it's going to be similar to the second example. Our nums1 is going to equal to 0, and then the m is going to equal to 0. So this is basically saying that our nums1 has 0 elements inside of it. Our nums2 is going to be equal to 1, and n is going to equal 1, and then finally our output is going to equal nums1 equal to, and we're going to take the value out of nums2 and then transfer over to nums1. So now nums1 is going to equal to 1. This is going to be another one of those problems where we're not actually returning anything. The code is just going to take a look inside of it and see if things are working properly, I believe. So these are what our examples look like. Let's go ahead and hop back up and take a look at our constraints to see if we can figure out any more information about the problem, which might help us pseudocode our example. Heading back into our constraints, so we have a couple of things here. So the first constraint is that nums1.length is equal to n plus m. This is just basically saying that there might be zeros at the end to fit extra values. And then nums.length equal to n is that's just being basically saying that there's going to be n values inside of nums2. 0 is less than m, and n is less than or equal to 200. This is just saying that the total length of n or m is between 0 and 200. So we're going to either have 0 up to 200. Then just below this, we have 1 is less than or equal to m plus n is less than or equal to 200. So this just basically means that the length of nums1 is between 1 and 200. This is probably going to have a little bit of implications on the top one as well, but I'm not too concerned about it. This is also not that big of an array. So theoretically, if you wanted to brute force this, it's absolutely fine. You could do that. And the final constraint is just saying that the nums of I or j could be negative 10 raised to the 9 to 10 raised to the 9. This is basically just saying that the numbers actually inside can be very large numbers. This is also going to make it so it's not necessarily possible to just use the largest value of integer or whatever. So if you're trying to compare against like a very large number to figure out what's max or whatever, you'd have to end up using infinity or something. But we don't need to worry about that because we don't need to really compare them to very large or very small numbers. We have another way of actually solving this. If we go back through and think of like all of the knowledge and everything that we have gotten from this problem, we can actually use this to think of an O of n solution that also allows us to go ahead and edit our nums1 array in place, basically meaning we don't have to create a new array that puts things together and actually has to go and copy back into nums1. So if we go back to the description of the problem, so if we go back into the original description of the problem, we can go ahead and see they put a lot of emphasis on non-decreasing order and non-decreasing order. So this basically means that they want the smallest numbers at the front of the array and the largest numbers at the end of the array. We can actually use this knowledge to help us sort out the array. So what we could do is we can, instead of checking to see if the numbers are smaller at the front, we can go backwards through the array and check the largest numbers first. And the reason that this is going to work is because if you remember, inside of our example here, there's a bunch of zeros at the end of the nums1 array that we could just go ahead and slot numbers into. So basically what we could do is we can do something similar to a 2-pointer where we can check the values of each side and see which one is smaller or larger and then go ahead and put them in the correct index. So let's go ahead and go into our pseudocode and take a look at what this might look like, and then we'll go and run through an example before coding this onto LeetCode. For our pseudocode, we're going to know that the nums1 array is always going to be larger than nums2 array. So what we're going to want to do is say while we have not placed all values from nums2 into nums1. So while we haven't placed all those values, we want to go ahead and check if nums1 of current is greater than nums2 of current. So if nums1 of current is greater than nums2 of current, we want to go ahead and set nums1 index, the current index that we're trying to set, equal to the nums1 of current. Otherwise, we want to do the opposite where we set nums1 index equal to nums2 current. Each time that we do this, we want to go ahead and say index minus minus. We'd also go ahead and have to keep track of what the current value of nums1 or nums2 is. And then after we're done placing all these, so after placing all values of nums2 into nums1, that means there are no more steps to take, no more values to check, exit the method. We're done basically. So we can loop through all the values inside nums2, check to make sure if they are smaller or larger than the value currently at nums1, and then either swap them or keep them in place, and everything is fine and dandy. So this may be a little bit confusing. So let's go ahead and take a look at our example and walk through this to see that it's going to work properly. So for our first example, we're going to have nums1 equal to, and it's going to be equal to 1, 2, 3 with 3 zeros at the end. Our m is going to be equal to 3 because we're only focused on the first 3. And then nums2 is going to be equal to 2, 5, 6. And then n is going to be equal to 3 because we're worried about all 3 of them. As we mentioned before, we're going to iterate through all of the values of nums2 until we've placed them all. And whenever we haven't placed them all, that's when we're going to be finished. So for our first iteration, iteration 0, current value 1 or C1 index is going to be equal to index 2. And then C2 index is also going to be equal to 2 because we're starting at the end of each one of these. And then on top of this, we'll also go ahead and say nums1 of C1 is equal to 3, and nums2 of C2 is now equal to 6. And then the index that we're looking at, index is equal to 5. So obviously 3 is less than 6 in this instance. So we want to go ahead and set our nums1 of index equal to 6. And in this case, we want to go ahead and decrement last minus minus, and we also want to say C2 minus minus because we've placed it. So now for I equal to 1, now our C1 is still equal to 2, our C2 is equal to 1, our nums1 of C1 is still equal to 3, and our nums2 of C2 is equal to 5, and our index is now equal to 4, and this last should actually be index minus minus. So now we need to once again check. So here 3 is still less than 5. So once again, we're going to go and set nums of 1 index equal to 5, decrement our index, and then go ahead and once again say C2 minus minus. Now iteration equal to 2. Now we're going to have C1 is still equal to index 2. C2 is now equal to index 0. Nums 1 of C1 is equal to 3, and nums 2 of C2 is now equal to 2. Now at this point, 3 is greater than 2. So now we want to go ahead and set our nums 1 of index equal to 3. And then we're going to go ahead and say index minus minus and C1 minus minus. For I equal to 3, we'll have our C1 is now equal to 1. Our C2 is equal to 0. Our nums 1 of C1 is equal to 2. Our nums 2 of C2 is equal to 2. Now at this point, technically 2 is not greater than 2. So what we could go ahead and do is we can say set nums 1 of index equal to 2. We'll have index minus minus and C2 minus minus. Now at this point, our C2 is equal to negative 1. So I equal to 4. C2 is equal to negative 1. So that means we're finished. So break from the loop. And now our nums 1 is going to be equal to 1, 2, 2, 3, 5, 6. And now it's going to be sorted from smallest to largest. So let's go ahead and hop into LeetCode, where I'm going to try my best to actually type properly and not typo anything. And let's see if this thing works as we expect. Back inside of LeetCode, let's go ahead and start out with a couple of variables. Firstly being int C1 is equal to m minus 1 as we had before. And then int C2 is equal to n minus 1 like we had in our pseudocode. And finally, our int index is going to equal to nums1 dot length minus 1 because we want to start at the end of our nums1 array where we have zeros. Then we're going to say while our C2 is greater than or equal to 0, as we did in our pseudocode, we'll check if our C1 is still greater than or equal to 0, and if our nums1 of C1 is greater than our nums2 of C2. We still need to make sure that we haven't gone out of bounds with our C1, obviously, or nums1. If this is the case, our nums1 of index minus minus is going to be equal to nums1 of C1 minus minus. So go ahead and decrement those. Otherwise, we're going to have our nums1 index minus minus is equal to nums2 of C2 minus minus. And this should go ahead and wrap it up. Whenever we get through all of our numbers inside of nums2, this should go ahead and return. So fingers crossed I didn't typo anything. Let's go ahead and try to submit. As we see, we get a beats 100%. We can make it a little bit more efficient with our space complexity, but I'm not that concerned about it. And this is how we can do a very simple solution to merge sorted arrays. I hope you all enjoyed and you learned something inside of this explanation. As always, my name is Ethan Coder. If you did enjoy, please make sure to like, comment, and subscribe. I hope you all have a great day, and I'll see you guys in the next episode.